Hello students, welcome to the video lectures of speech and natural language processing. So today we are going to discuss about the various issues, okay, in POS tagging and also the entropy. So what are various issues that exist in our parts of speech tagging? So parts of speech tagging is the process of assigning a grammatical category. Grammatical category is nothing but tagging the correct parts of speech, either it's a noun or verb or adjective, etc., to each word in a sentence is a fundamental task in natural language processing, right? So this is what we basically do while we do this parts of speech tagging. So if for a given sentence, we have to tag what is noun in that, what is verb in that, what is adjective in that, and etc. So what are the issues found in this? So till previous lectures, we have been seeing the previous POS tagging techniques and all those things. Now we'll talk about the issues that exist in the parts of speech tagging. So since we have learned many other issues that exist with other NLP techniques or topics that we discussed in our previous video lectures, so as this POS tagging also, which faces some kind of challenges. So let us discuss each one in detail. So first one is ambiguity in language. So ambiguity is one of the major issues in POS tagging. It is the inherent ambiguity of natural language. So many words can belong to more than one part of speech depending on the context. So how we can illustrate this? Just you can consider an example of a word called book. So earlier also were discussing about this particular word called book. Okay, so I read a book. I want to book a flight ticket. Okay. So now you can see that book in these two sentences have two different meanings, right? So here it is, I read a book, whether it is a noun or verb would be an ambiguity for the language. So as far as this sentence is concerned, I read a book is a noun. Here, I want to book a flight is a verb. Okay, here it is noun, here it is verb. So this sort of ambiguity exists in the POS tagging concept. So next is about the entropy in ambiguity. So entropy measures the uncertainty or unpredictability of a system in the context of POS tagging. So high entropy indicates that greater uncertainty about which the tag is assigned to a word. So why there is an entropy in ambiguity is it is because of this uncertainty or unpredictability. So how I'll tell you, for example, if we take a sentence called he can fish. Okay. For a word, he can fish. The can could be, the word this can could be tagged as a verb. Okay. Or sometimes it can be tagged as a noun. Understood? This is what the uncertainty or the unpredictability that exists. So next we see out of vocabulary words. So this is another challenge that what our POS tagging will face. So what is this out of vocabulary words and why this is a challenge. So another significant challenge in POS tagging is handling of out of vocabulary words, words that are not present in the training data. So this issue is particularly relevant for low resource languages or when dealing with the domain specific text. So example are legal or medical documents. Okay. So then entropy in out of vocabulary word handling. Okay. When the tagger encounters out of vocabulary words, it experiences high entropy because there is no prior information such as transition or emission probabilities in an hidden Markov model. Okay. So to rely without sufficient information about the word's possible tag, the system is left with uncertainty, increasing the likelihood of errors. So how we can say this is, let us imagine you are training your model with some, some traditional English, okay, on some general English. You are just training your model on general English, right? Understood. Now, suddenly, let us imagine it's going through a medical document and it faced a term called angioplasty. Now, what happens? Obviously, it leads to high uncertainty. Since this is a word which it doesn't know, this is called as out of vocabulary words. Okay. The next is about data sparsity. So data sparsity refers to the challenge of having insufficient annotated training data for less frequent words or specific linguistic constructs. So most supervised POS tagging models require a large amount of labeled data to accurately predict POS tags. However, collecting and annotating such data is time consuming and expensive, particularly for rare words or low resource languages. Next, entropy in data sparsity. So now, what is this entropy in data sparsity is in sparse data sets, the entropy of the system increases. The entropy of the system increases because the tagger lacks sufficient examples to learn the correct tag sequences. So low frequency words and phrases cause higher uncertainty in prediction. So high entropy can make the model more prone to overgeneralization or overfitting. So how, just let me tell you this with an example. So already you know that what is data sparsity since we are discussing in our previous video lectures as well. Suppose say, similar to previous example, this is a model which we are, training. Suppose this is the model which we are training and this is being trained with some small data set. Okay, there is a small data set we have considered. Okay, this is that small data set and just we trained with this data set to our model. So whenever there is a word that has been rarely used, is being encountered by this model, it cannot answer it. We can say that it is like unpredictable. Okay, through which our model will fail. So for example, I'll tell you, when we consider a small data set, there are some particular rarely used words which we haven't, trained our data set on. For example, flabbergasted. Let me write flabbergasted. So, which means, an extreme surprise or shock or ephemeral, which means which lasts for very short time. So there are a couple of words like these, which are rarely occurring words, we say, which are domain specific, or sometimes they may be some domain specific jargon, or some other words which we haven't trained on. So then, which will definitely lead to some unpredictable tagging performance. So that's the issue with out of vocabulary words. Sorry, data sparsity. Then tagging of unknown or rare words is the next issue. So what is this tagging unknown or rare words? So unknown or rare words, especially names, acronyms, or newly coined terms, neologisms like selfie, pose problems for what is neologism? So it is the new words or phrases, okay, that are added to this. Then problems for POS taggers. So rare words might not appear frequently in training data, leading to inaccurate predictions. Obviously, when the model is not, trained with some particular category of words, and if the model is being encountered with such kind of words, it cannot answer such words, right? This is a general principle. So entropy in rare word tag. So the entropy increases when the tagger encounters a rare word because the model cannot rely on previously seen data or learned probabilities. So the tagger's predictions will often be uncertain and more prone to errors. So when we talk about this neologism, so the example given is like selfie. Selfie is something which is taken by a smartphone or mobile, right? So when such words like selfie is encoded for the very first time, and the POS tagger, which is trained on, our model or our POS tagger, let us say, our POS tagger has been trained on some traditional corpora. So when I say traditional corpora, it's a traditional database or data set, we can say. So this, then when we train our, this POS tagger with such traditional corpora or database, it will definitely struggle to predict whether it is a noun or an adjective or some other POS. Okay. So thus our entropy increases. I mean, it is a tough task for our tagger to tag such words. This is about your tagging unknown or rare words. So then complex sentence structures. So in some cases, long or complex sentences can make POS difficult. Sentence with subordinate clauses, embedded structures, or unusual syntax may lead to errors in tagging. So as the relationship between words become harder to model. So long or syntactically complex sentences tend to have higher entropy as there are more possible word combinations. and syntactic dependencies that the model must account for. So the tagger has to choose the most likely sequence of tags from a larger set of possibilities, increasing the uncertainty. So when we consider some, long sentences, I think we can just understand. So let me write one sentence and let us try to understand this, why this is a challenge. Suppose the man who the teacher said was late arrived. So now we can see a combination of or a complex sentence with a different clauses, which makes this model, pose a challenge by these kind of sentences. Okay. So because these have some multiple clauses and complex word relationships, which is very hard for any kind of model to predict. So then cross-domain generalization. So when we say cross-domain generalization, so it is our model is trained on a specific type of corpora, that is a corpus, or let us say it's a news articles, may not perform well on other domains. For example, social media or legal text. Understood? Now this is the our NLP model which has been trained with news articles. Now you are asking it, or it is being encountered to get a result by giving the input as some text which belongs to some social media. So this poses a challenge here. So different domains often exhibit different vocabulary, syntax, and stylistic variations, leading to increased uncertainty. So when a POS tag trained in one domain is applied to another, the entropy increases due to the unfamiliarity of the new domain linguistic patterns. So the tagger faces increased uncertainty in assigning correct tags since it was not trained. This is what is important on the data representative of the new domain. Clear? So when you try to give some certain input uh, of some informal grammatical tweets that which you take from your Twitter or any other social media platform, it becomes difficult for a tagger who is trained on some formal news articles, right? That is what cross domain generalization is. So entropy in probabilistic models. So entropy is a key concept in probabilistic models such as HMM, we call that is hidden Markov models, and maximum entropy models, maximum entropy Markov models, so which are commonly used in POS tagging. So first is HMM. So in hidden Markov model based tagger, so entropy is directly related to the transition and emission probabilities, right? So what are these transition and emission probabilities? Already we have seen in our previous lecture. So when I say it's a transition probability, it is the likelihood of a tag given the previous tag, right? And when I say emission probability, it was the likelihood of a word given a tag, right? These probabilities are ambiguous. The model will have high entropy and make less confident predictions. Next, the entropy with our maximum entropy models is maximum entropy models uses features from the input data to predict POS tags without making strong assumptions about tag dependencies. They aim to maximize the entropy of the system to avoid biased decisions. However, in ambiguous or data space scenarios, the entropy may remain high, reflecting uncertainty in the predictions. So summarizing the entire thing, so whatever the challenges that we have seen till now, it basically deals with your low resource languages or some domain shifts or out of vocabulary words, or it goes on, the list goes on. So there are certain challenges to make this POS tagging an efficient one. So only thing what we can proceed further is to through some better models or giving some rich data sets would be the best solution for improving the accuracy and the robustness of our POS tagging systems. Okay, students. Thank you.